Okay.
Okay, so I'll just share my screen.
Share this. Yeah, we can go ahead.
So let me share my screen. Hopefully that's visible.
Yeah, it's visible.
And readable because it's quite small. So what I'm going to do is today was just to walk you through deploying Weka onto a system. What I've actually got, these nodes happen to be running in AWS because that's where I've got access to systems, but it applies equally to any cloud vendor because we run on standard Linux, or it would apply to physical hardware on premise. So what I've got is I've got 6 nodes with set up with parallel shells. So I've got a passwordless SSH set up between them to make my life a bit easier. I don't actually need that, but it makes my life a little bit easier when I'm deploying the software. And on this particular one I've just SSH'd into one of the nodes, and that node I've got a copy of the Weka software. So tar.weka version 41077 as a tarball. So I have downloaded that already. If you want to get access to Weka, you get that from get.weka.io, and I can log in with my Google account. But we have our releases, and anyone who wants access to the release, you can click download once you've got an account, and you'll be able to download the software. I've just already done that just to speed this up. So these are relatively small nodes, LS CPU. There is single socket, 4 physical cores, 8 threads, and a little bit less memory. I think about 66 memory, so not huge nodes. And LSBLK, I've got a couple of free NVMe drives, NVMe 2 and NVMe 2N1 and NVMe 3 are the NVMe drives. And like I say, I've got 6 nodes with PDSH SW, and I've called them B0 to 5. Let's just now running as it's in AWS. They're running Amazon Linux 2, which is CentOS RHEL version. So basically 6 nodes with the specification I've shown you, just running the standard Linux distribution. Like I say, I've added the EPUB, the repository in PDSH just to make my life easier, but I've done nothing else to the boxes apart from that. And so there's a couple of things to make life easy that I would do. So I've downloaded the Weka software onto just this one node, onto one of those 5 nodes. B1 I'm actually connected to, but the other thing that is useful to get is the Weka tools. Because we've got a number of tools to help. I can't type. Which give you a number of tools to be able to work on a deployment to speed up and make the deployment a little bit easier. So I'll just quickly clone those onto this machine. Well, I won't go through all of the tools, but I'll show you. So we've now got the tools directory. See the tools, and in here we've got an install directory, and we've got some tools specifically aimed at speeding up the install. And one of them is Weka Checker, which is text that makes sure everything is set up correctly. And I can do run it across wrong brackets. Run it across all of my nodes, and it will just check that each of those nodes is set up. Some of them, and okay, some of them it warns about. The only fails we're going to get is Mellanox offhead, which we don't need to worry about because this is not an InfiniBand connector. This is an Ethernet connection. If you're using a Mellanox 64567 these days card, then we need the Mellanox offhead installed, and just the release, because this is running, it doesn't actually recognize the AWS Linux, but everything else is a pass. And that's just a quick check to say that everything is set up on these boxes to make sure that Weka will install cleanly and that we won't have any issues. That's the Weka checker. And then the other useful one that we have in the install is Weka deploy. And what Weka deploy will do will simply copy the tarball from the machine I'm on to all of the machines, untar it, and then just run install.sh to install the Weka software. So I can just Weka deploy, then the version of the tarball. Hi, Mark.
Oh, hang on. Sorry. Hi.
So nobody's joined. So what we're just doing is recording the deployment, just so we've got it as a recording.
Okay.
So I've just gone through. I've just shown people the hardware we've got. I've got 6 nodes in AWS. I've just run Weka checker, and I'm now just going to run the Weka deploy. To the 6 nodes that I've got. So that's just going to run the Weka deploy to the 4.1 tarball to those nodes, and that will ask me to just check I've run the Weka checker script, which I have, but it was clean apart from the items that I pointed out. And that's a typo. We haven't got 55 nodes, have we? Not my day today. One thing I should do. So basically what this will do is it'll just copy the tarball to each of the nodes in the cluster, and it will then untar them, and then it just runs install.sh. That's inside there, which installs the Weka software onto each of the nodes. So this will take a few minutes just to run. I see that the Weka tools are there available on GitHub. So there's a number of tools like to help with the install. There's also a little wrapper around FIO Weka tester, which runs some basic performance testing, which we can probably run at the end of this, which just allows you to just validate that the system's up and working correctly. So it's taking another minute or so. Typical. I'm going to have to tidy up. Never demo anything. PDSH WB 0.5. Okay. Unfortunately, I hadn't tidied up correctly after myself, and B1 still had it installed. So now let's try that again. Sorry about that. This will be a bit quicker this time because it doesn't actually have to copy the tarball because so that's installed Weka. So if I do a Weka, I can now run Weka local PS on this machine because this is one of the nodes in the cluster, and I'll see that we have a container running called default. and it's in STEM mode. And STEM mode basically means the software is installed, it's sat there ready, but it's not part of a cluster. It's not aware of anybody else. It's just like a stem cell. It's ready to be turned into a Weka cluster. And again, actually, that will have happened across all of the nodes in the cluster. So if I look at all of the nodes, you will see that's the case on all of the nodes. They're all sat there. They're all got the container called default running, and they're all in STEM mode. So they're all running version 4.1077. So systems deployed, but because it's just sat there, they're ready to be formed into a cluster. Now we've installed not only the core, we've installed the Weka agent. You now have, let's say, the Weka command line. So if you're looking at, I can do the Weka local status. Tells me what's happening on this particular box. I like to say, and it shows that you've got one container running, and then it's in STEM mode. And so the next step is just to create a container and start there. All of the commands that I'm going to be using are documented on Weka docs.weka.io, so you can have a look there, and you can follow along. But this, I say, the idea is just to show you how quick and easy this is. And basically, the next step is I've now got these nodes, the software is running, it's sat there in STEM mode, is just to create a cluster. And so, Weka cluster create. I'm going to use B, those nodes, except it's got to be that bracket. Why can't I got my brackets right today? And then the IP addresses of those nodes. Now I've actually got these written already. So each IP address of each node, comma separated 1, 2, 3, 4, 5, 6. So that's the nodes and their IP addresses. So I've now created a cluster. So now where do a Weka it's no longer in status mode, it's in ready mode. So we have a cluster, it doesn't have any resources, but the software is now, each node is aware of each other, they're now acting together as a cluster. And then I need to, as it's said in the example, I now need to add the various resources that this cluster will use, the drives you wish it to use, set up how many cores you wish it to use, and then apply those settings. And then basically you can start IO. So what I'll do is for each node, to add a drive to a cluster, it's Weka cluster drive add is the command, and then you specify which node you want to talk to and which drives you want to add. But just to speed things up, I will do that in a loop. I will do all nodes with the command. So I'll basically, each node is identical. So what I will do is I'll just run a command. So I'll do for I in 0 to 5, do a Weka cluster drive add. So for each node, 0 to 5, add these two NVMEs, NVMe 2 and NVMe 3. So it'll go to each node in the cluster and tell it that it can use these two drives for Weka. So that I'll run through pretty quickly because there's those drives have been used before. So I've now added those drives. So each of the 6 nodes is being given access to that NVMe drive. And then I need to say how many cores I wish the system to use, which is a container. Each container, you can define how many cores you wish to use. And basically, Weka is truly software defined. The more cores you give it, the faster the performance. And we can dedicate cores. So on large systems, we may dedicate cores to drives to actually manage the NVMe drives. We can dedicate cores to the processing, the erasure coding, what we call the compute cores. And then we have front end cores, which is what we use for client access. So if you're building a large, very high performance system and you're looking at doing hundreds of gigabytes a second on dedicated servers specifically for Weka, then you might wish to be allocating, a number of cores specifically to Weka to do this. This is a relatively small machine I've got. It's only got 4 physical cores, and therefore I'm just going to set it up so that I'm only using actually a single core for this, just because for demonstration. But I say performance is directly linked to resources. With Weka, it's effectively truly linearly scalable. So again, for each node, for nodes 0 to 5, I'm going to do a Weka cluster container, and I'm going to set it to use 1 core. Just as now, I could use 2 and leave 2 spare, but I'm just going to use 1 for this. And now for the Weka cluster containers. It hasn't set it yet, you'll see, because I haven't applied those settings. I'm just telling the system what I wanted to use. I also wanted to tell it which network interface to use. So I'm just going to do that, because obviously it's up to you which network interface you can use. If I look at IPA, I've got a number of networks available, but I'm going to use ETH1 here for that. So if I can tell the system to add that network interface to be used. And again, the same thing for each of the nodes, do a Weka cluster container, add for each ETH1. And that will just go away and add ETH1 to each node. And again, still, if I look at the containers, it doesn't actually show that because I need to apply those settings. I'm just going to tell it to go away and to apply those settings I've made to each thing. And basically what will happen is the system will restart the containers with those local settings. So you see if you just do a local PS, you can see that it's restarting, so it's rejoining the cluster, and then it comes back to status ready. So that means it's done. And now if I look at Weka containers, you will see of the nodes I've got, these are their actual host names. Like I say, I've got them as B0 to 1, but their actual host names. Each one's running a container called default, running which version it's running, and it's using a single core. So I've now got effectively a Weka cluster ready to go, and I can just do Weka cluster start IO, and that will hopefully starting up the drives now, and it brings up the buckets. The buckets are how Weka shards the file system. They are the metadata containers, the erasure coding. So that's what is we distribute the metadata across the cluster. So that's how the file. And at that point, we have a cluster which is fully up and ready to go. And at that point, you could also connect to the GUI. So let me just get if I just get the public IP address for one of the nodes. I have config.me. Not sure because this is on AWS. I need to get a public IP. So I will be able to go to a browser and connect to that. Wow. I highlighted the wrong thing there. Connect to the IP. On port 14,000, which is the management port. And the cluster's up and running. The default user is admin and the password is admin, but it will force me to change that. My password keeper, don't need that anymore, admin. I'll change it to something different and then log in again. And that brings up the Weka GUI. So I've now got a Weka system. It shows you the backends with the nodes. Tells you, so I've got 6 backend servers, each using a core, so 6 out of 6 cores, and each with 2 drives. So I've got 12 drives. So that's the basic thing. So it's a cluster. It doesn't have a file system yet. It's not able to do I/O, but it does actually have that. And you see, you can manage it via the GUI. So I can go manage file systems, and I can create file systems. Or you can do it via the command line. So I could do Weka FS, although this will fail because I've changed the password. When I went to the GUI, I changed the admin user, so that caused it changed. So it needs to do a Weka user login again. To re-log in is admin, and using the admin password I've just changed. So now I can look at file systems. So there are no file systems now. I could actually create a file system via the GUI, or I create a file system via the command line. Each file system on the system sits within a file system group. So you've got to create a group first. So Weka FS group create, say, a default group. And they are used for policies if you're going to bring in tiering in the future. So you're going to start tiering down to an object store. The policy is set at the group level. So I can create a group. And then once I've got a group, I can create a file system, create FS1 in group default. I need to how big I want it to be. Let's have it to be 1, 2 TB. So Weka FS, I've now got a 2 terabyte file system. And I also, you'll see the same here, the default file system group I created here. And now I've got a file system called FS1, which is in the default group. I can edit it if I wanted to. Here I could change the capacities. But at this point, the system is effectively, I've got a file system. I've got which is set to 2 terabytes out of the available capacity. I can change that file system online via command line or the GUI, but it's now ready to mount. Now, let's say at the moment, especially what I'll do is I can mount that file system directly on these nodes, the backend nodes, because it's not available at the moment. If I do a DFH, it's not actually mounted at the moment. I say I can I'll do is I'll create a mount point across the nodes. Mount Weka is always a good one. And then I can mount the file system. Oh, I can learn to type as first. So the type is Weka FS. I want to mount FS1. I want to mount /mount/Weka. I say you can use -O and you can do various resources which are documented, but I'll just do a basic mount. So now if I do a DFH, I've got FS1, which is 1.9 terabytes on mount.weka. And you can, like I say, edit this in real time. I can make it 4 terabytes. It's changed TB bytes, or I can shrink it down as well, you know, if you want it to be less. So you have that ability to create that.
So if anyone's, can you hear me, Dave?
Yep.
Yeah, so I say if anyone's using this in the lab or anyone's using this as part of their projects at ISC, please reach out to Dave and me. We can help you set this up. Obviously, if there's questions around how you mount the file system, how you run jobs against the file system, obviously we can do that. If anybody's got any further questions, we can even supply you with scripts for creating Weka on a single machine, right? It's not ideal, but we can obviously do that if you decide to use Weka. But that was really great, Dave. Thank you so much. Really helpful.
So I say this is running across these hosts. So we're running a container, one on each host. As Mark says, there is an option to run it on a single host, and what we effectively do is run multiple containers on the same host. So if you don't have, the minimum for a cluster currently is 5 nodes, or 5 containers. So if you have a host which has 5 drives in it, then you could run it on a single host with 5 drives, or you can run it across 5 hosts, each with 1 drive or 2 drive or 3 drives. But we can run that on a single host. But you know, that's fundamentally how quick and easy Weka is to deploy. You simply add set the software up, add the drives to it, tell it which Ethernet ports you wish to use, and then apply the resources, and then you can mount the file system. So I can now cd to /mnt/Weka. There's nothing there. I probably haven't got permissions. Yeah, no. it's a test environment. But I can do that. It's a parallel file system. If I do a PDSH, see, I can see the thread from every single node. There's a parallel file system, which is mounted on. And then if you do want to do base, you can basically run IO against that as a parallel file system using the POSIX client.
Yeah. Let me ask something. So eventually you use all the drives available on the nodes, right?
You can do. You don't have to use all of the drives. You decide which drives you wish to have access to. But generally speaking, especially if Weka is running, if you've got a dedicated node as the Weka cluster, then yes, you would use all of the drives. And we basically, if I do an LSBLK now, you will see those drives, because of the way Weka works, we use the whole drive. We take that drive effectively away from the operating system, so they're no longer visible. So we've taken NVMe 2 and 3. They're gone as far as the operating systems because they're now owned by Weka. But so I'm not using these two drives because they've been used. One's NVMe 0's got the OS on it basically, and NVMe 1 has /opt/Weka, which is a partition where we've installed the Weka. We put traces and stuff in. But yes, you don't have to use all the drives, but we do. But we normally you would do because you're looking for the best performance and capacity.
And then eventually, what happens on the underlying? You save the file in a specific location, specific drive. Each time you split it across.
We erasure code it across all of the drives and all of the machines. So and we do that at a 4K block level. So we are striping across all of these 6 nodes. So so across each one of these nodes, when you write that file, we will be doing erasure coding and we'll be striping it across all of the nodes and ensuring each node at this moment is in a failure domain. So we'll make sure there's a part of that file across each node and not 2 parts of a file on the same 2 disks in the same node, as it were. So that by default we use an N+2, so we could actually lose 2 of these nodes and still have full access to the data. Yes. So you get data resilience. You get an N+2. We can do N+4 as well if you're using very large clusters. That may be useful, but generally we'll protect you and we will auto rebuild. You can add nodes to the cluster online. So in the cloud, for example, we see people using auto scaling groups. So as the workload increases, they can add nodes to the cluster, and Weka, because it is a linearly scalable. As you add, if you start off with 6 nodes and you're getting, I don't know, in a cloud environment, 20 gigabytes a second. If you scale that to 12 nodes, you get 40 gigabytes a second. You scale it to 18 nodes, you get 60 gigabytes a second. It's if they're the same configuration, you'll get linear scalability as you add nodes, and you can add and you can shrink back based on demand and workload, so that if you need extra performance during certain computation, you can add nodes. And that also applies on premise, but obviously the cloud has a lot of auto scaling scripting already set up.
Once you add the nodes, you rearrange the data with the erasure coding again. So let's say you double the amount of nodes. The one you already wrote has to be rearranged.
No, we don't restripe existing data. We will balance new writes onto that, and if you then take nodes away, if we take nodes away, we will have to rebalance them back. But by adding nodes, no. If you deploy a cluster initially, say an 8-node cluster, and you did a 6+2 stripe set. If you add more nodes, we'll still only do a 6+2 stripe set, but we'll distribute those stripes across the nodes. So not all nodes. So when you do a particular stripe,
it'll be different 6.
We'll get spread around the node, but we'll always ensure that you only get one piece of each stripe on each node, as it were. So you still have that resilience. So we dynamically monitor all the command queues to all of the drives, and we will basically, as the workload increases, we will bias workload to new or quiet or empty nodes to make sure the system is fully optimized.
Okay. Regarding the procedure you just showed, do you have like a good like a cheat sheet or like, you know, easy getting started page that will show the commands that you just showed now. So
absolutely. So
people can refer to that.
docs.weka.io is the place to go. So version 4.1 is the current main release, which is what I've just deployed. Yes. And we have a quick installation guide.
Okay, yeah.
So I'm on if you're using AWS, and we've also just added Azure and GCP down here for prerequisites for installation, but bare metal installation, it walks you through, you know, I'll not go through planning, but memory requirements, you know, network planning, you know, making sure you've got the NICs and everything installed. That's all sort of stuff that you need to do if you're using InfiniBand. But then eventually, once you've got through all of this, it says run Weka checker, which is what I did. We'll skip enable an SRIOV because that's almost certainly, that tells you how to download the software from Weka, getweka.io, and then eventually installing the Weka software. Tells you what all of the commands are, how to install it. You should be able to completely walk your way through it. All this is publicly available. Set up the containers. And I see we're also here to help. Obviously, we're on the Slack channel. We also have, as Mark mentioned, I have a single, if you wanted to run on a single server, I have a single server script here, you know, which would show you how to install Weka. So instead of having these Weka cluster, at the moment I've got one container called default running on each of the 6 nodes. I can actually create 6 containers on one node. To Weka, it's the same, because when we're doing our erasure coding, we're doing our striping, we're striping data across containers. Now, obviously, for best performance, you run one container per node with the maximum resources, you get the best performance. But it works equally well if we just say, actually, we'll just run 6 containers on one node, or maybe possibly 3 containers on one node and 3. You don't get hardware resilience, because if the hardware fails, then obviously you're there, but you can still run the Weka software. So rather than running it across 6 physical hardware devices or virtual hardware devices, basically we have commands which basically will create multiple containers, default 1, 2, 3, 4, 5, and I'm missing one there. On the same, so we can build that. So we can work in all sorts of configurations. Obviously, it's just a case of then matching performance to what you're getting.
Okay. Thank you, David. Do you have any questions?
No. Sorry.
No, I have David Chow. I'm asking David Chow.
Okay. Sorry, I didn't realize you joined. Sorry.
Okay. Yeah, go ahead.
No, I was going to say, well, let's say, as Mark said, if anyone wants to get access to the software, wants to have a go at trying to install it, they can do it themselves. If they want, we're on this the shared Slack channel. We are happy to work with you to support you in trying it, and we can discuss the prerequisites, what clusters you've got and what resources. And I say we can either do it on across multiple nodes, or if you don't have that many nodes, or you have other hardware restrictions, we can do it on a single node. But where Mark and myself are here to help with anyone who would like to explore using the Weka software.
Okay. Thank you so much for the demo. I'm going to upload the recording and send it to the teams, and continue from there.
Yeah, please reach out. Any questions at all anyone has, Dave and myself on Slack or on email, absolutely happy to help. If you want to do some benchmarking, we're really happy to jump on and help you set something up. No problem at all.
Okay. Sounds good. And see you, I guess, on the ISC.
Yeah.
You're going to be there, right?
Yeah, we'll be there.
Yeah. Thanks, Dave. Great job.
Okay. Thank you, guys.
Take care.
Bye. Bye.